It was the night of March 23, 1945. Along the banks of the Rhine, near the shattered German city of Wesel, the air trembled with the echo of artillery and the constant hum of engines. Thick curtains of smoke rolled over the water, spreading from hundreds of generators placed by Allied engineers to hide the movement of men and machines. Beyond the haze, flashes of explosions lit the eastern horizon, where German guns continued to resist the inevitable. The Rhine, swollen from spring rains, flowed dark and restless, cutting Europe in two, between the Germany that still fought and the Germany about to collapse. On the western bank, under the ghostly light of flares and burning towns, American combat engineers prepared for the task that would decide the success of Operation Plunder. Among them were the men of the 17th Armored Engineer Battalion, attached to the U.S. 9th Army. Their mission was to assemble a floating treadway bridge, an M2 pontoon span long enough and strong enough for tanks, trucks, and endless convoys of supplies. It was to be the largest river crossing the Americans would attempt in the European theater, and it had to be completed while under fire. For weeks, preparations had been meticulous. Hundreds of flatbed trucks carried the heavy steel treadway sections and inflatable pontoons to the river's edge. Anchors, cables, and winches were laid out in precise order. Artillery units were already pounding the opposite bank, while aircraft from the Royal Air Force and the U.S. 8th Air Force bombed Wesel into silence. But the enemy was not gone. German spotters and artillery batteries, hidden in the ruins across the river, were waiting for the smoke to lift. The engineers knew that once the first pontoon hit the water, the enemy would start shooting. The soldiers worked quietly, muffling every metallic sound with rags. Each movement was calculated, each tool checked twice. They wore darkened helmets, their faces streaked with mud and oil. Around them, the entire riverbank had become a hive of controlled chaos. Jeeps bringing ammunition, cranes unloading sections of bridge, signalmen laying field telephones, medics standing by with stretchers. Every man knew that at dawn, thousands of troops from the 30th Infantry Division and 79th Division would depend on this bridge to cross the Rhine. At 9 p.m., the first assault boats began to slip into the current, carrying infantry under cover of artillery fire. The engineers followed behind, hauling their equipment through the mud. By midnight, the first M2 pontoons were in position, inflated and anchored against the current. Each weighed nearly a ton, yet the men handled them as if time itself were pushing from behind. The roar of artillery covered the sounds of hammering and the clank of chains. The treadway sections, steel panels forming the roadbed, were lowered onto the pontoons, bolted together with practiced precision. The structure grew foot by foot, stretching from the darkness of the shore toward the smoke-veiled opposite bank. The Rhine reflected the burning sky like molten metal. Pieces of debris floated downstream, branches, wooden beams, sometimes the shadow of a destroyed craft. Overhead, Allied bombers roared back toward England, their mission completed, leaving behind only the rumble of artillery and the heavy breathing of soldiers at work. Every few minutes a shell landed nearby, sending fountains of water into the air, but the engineers did not stop. They had been told that the bridge must be ready by morning, no matter the cost. By 3 a.m., nearly a third of the bridge was already in place. The smoke screen shifted with the wind, revealing brief glimpses of the opposite bank, dark silhouettes, flashes of German tracers, and the glow of burning oil tanks. The men could feel the ground shake from tank engines warming up behind them. Soon, the armored columns would move, and this floating road would be their only way across. In that night of noise, flame, and water, the bridge became more than an engineering task. It became a lifeline between two worlds, one still locked in war and one already reaching for its end. Everything depended on those few hundred men, soaked, exhausted, and half blinded by smoke, piecing together the steel bones of a bridge that would carry an army. The Rhine had once been Hitler's boast of invincibility, the impenetrable wall of his Reich. Before dawn, it would become the pathway of its defeat. By the spring of 1945, the Rhine River had become both a symbol and a barrier. For the Allied forces advancing from the west, it was the last great natural obstacle before the heart of Germany. For the retreating Wehrmacht, it was the final defensive line, ordered by Hitler to be held to the last man. Every bridge from Cologne to Duisburg, from Bonn to Wesel, had been systematically destroyed by German engineers. Some had been dropped into the water weeks earlier, others blown apart just minutes before Allied troops arrived. What had once been solid arteries of commerce and travel were now twisted ruins of steel and concrete scattered across the flood-swollen river. The destruction of the bridges was not merely tactical, it was deliberate psychological warfare. The Rhine had always held a mythic place in German identity, the supposed line no enemy could cross. By demolishing the bridges, the Nazis hoped to slow the Allied advance long enough to reorganize their defenses on the eastern bank and perhaps buy time for political maneuvering. But for the soldiers on the western shore, the practical problem was immediate and brutal. Without a bridge, the American Ninth Army could not move its armor or heavy artillery. Supplies piled up on muddy roads, and the logistics of feeding, arming, and reinforcing the front began to choke. The offensive momentum that had carried the Allies from the Ardennes risked collapsing just miles from victory. The Rhine itself added to the peril. In March, snowmelt from the Alps and heavy rains in central Germany had turned the river into a fast, unpredictable current. Its average width near Wesel exceeded 400 meters, with depths reaching over 20 feet in some areas. The current was powerful enough to twist pontoon sections out of alignment, or snap their anchor cables if not secured precisely. Even in daylight, construction on such a river was dangerous. At night, under shellfire, it bordered on impossible. Engineers had to fight not only the enemy but also the river itself, a living, shifting force that punished every miscalculation. The Germans, though weakened and retreating, remained deadly. Artillery observers hidden in factory chimneys and church towers across the river could spot flashes of cutting torches or vehicle lights through the drifting smoke. Within minutes, shells would begin to fall, aimed not at infantry but at engineers, the fragile lifeline of any advance. Each hit in the water sent waves that rocked the half-built bridge, tearing bolts loose and bending sections out of shape. Repair crews worked waist-deep in freezing water, often rebuilding the same piece 2 or 3 times. Casualties among the bridging units were high, but replacements were scarce. Traditional bridge building procedures were useless under such conditions. Normally, engineers would use cranes and scaffolding, aligning beams with careful measurements. Here, there was no time, no machinery, and no clear visibility. Every movement had to be manual, improvised, and immediate. The supply convoys bringing steel treadway sections were delayed by cratered roads and wrecked vehicles. Trucks sank into the mud as artillery churned the riverbank into a swamp. To make matters worse, German counterattacks threatened the flanks of the bridgehead, forcing the engineers to work under the constant possibility of losing the entire site. Time became the most dangerous enemy. Every hour the bridge remained unfinished meant that infantry on the far bank had to hold their precarious positions without tank or artillery support. Each delay risked the collapse of the fragile crossing operation. Commanders knew that if the engineers failed, the entire momentum of Operation Plunder could be lost, giving the Germans a chance to regroup behind the Elbe. There were no reserves to fall back on, no alternative routes to cross the river in force. In the chaos of spring 1945, the Rhine was more than a geographic obstacle, it was a test of endurance, precision, and willpower. To cross it required mastery of both engineering and timing. Every bolt tightened, every anchor dropped, every plank laid under fire carried the weight of an entire army's fate. For the men of the engineer battalions, failure was not an option. The only path forward lay through the roaring, cold, hostile river that had stopped armies for centuries. By March 1945, the Western Front had reached its final and most decisive phase. The Allied armies, having fought their way through France, Belgium, and the Netherlands, now stood at the western bank of the Rhine River, the last formidable natural barrier protecting the heartland of Germany. Beyond that river lay the Ruhr, the industrial engine of the Third Reich, whose factories and rail networks had powered Hitler's war machine for 6 years. To reach it, the Allies needed to cross one of the widest and most heavily defended waterways in Europe, all while facing an enemy determined to fight to the end. Operation Plunder was conceived as the culminating strike of the Allied campaign in the West. Planned by Field Marshal Bernard Montgomery, It brought together British, Canadian, and American forces in a massive coordinated crossing. The operation's goal was not only to breach the Rhine but to establish multiple secure bridgeheads from which the Allied armies could surge into northern and central Germany. Montgomery's 21st Army Group, including the British 2nd Army and the U.S. 9th Army under Lieutenant General William H. Simpson, would lead the assault. It was designed to be a methodical, overwhelming operation, an answer to the chaotic improvisation that had characterized earlier campaigns. The strategic context had shifted dramatically just weeks earlier. On March 7, 1945, a unit of the U.S. First Army captured the Ludendorff Bridge at Remagen intact, a stroke of extraordinary luck. The seizure of that bridge allowed the Allies to establish the first crossing over the Rhine far ahead of schedule, shocking both the German High Command and even some Allied planners. The Remagen bridgehead proved the German defenses were brittle and that the myth of the Rhine as an invincible line had already been broken. Yet Remagen was only one crossing, far to the south. To achieve a full breakthrough and encircle the Ruhr, the Allies needed to cross the river with entire armies, not just isolated divisions. That was the purpose of plunder. The chosen location, around the city of Wesel, offered both opportunity and danger. The flat terrain of the lower Rhine made it suitable for armor and logistics once a bridgehead was secured, but it also exposed the attackers to German artillery and observation. The river here was wide, nearly 400 meters across, and lined with dikes that limited concealment. German defenses, though weakened, were still organized under the remnants of the 15th Army. They had artillery batteries positioned on high ground, minefields along the banks, and anti-aircraft guns repurposed for ground defense. For the Allies to succeed, they would need overwhelming firepower and flawless coordination. Preparation for plunder began weeks in advance. More than 16,000 engineers, mechanics, and logisticians were assigned to the effort. Massive stockpiles of bridging equipment, including M2 Treadway pontoon bridges, Bailey bridge components, rafts, and ferries, were gathered along the west bank. The logistical buildup was staggering. Tens of thousands of tons of steel, rubber, and fuel were positioned within striking distance of the river. Smoke units rehearsed creating artificial fog to conceal the movement of bridging teams, while artillery crews calculated firing tables for a 24-hour barrage. The air component, Operation Varsity, the largest airborne assault of the war, would coincide with the crossing, dropping British and American paratroopers east of the Rhine to disrupt German reinforcements. By late March, Montgomery's plan was complete. The British 2nd Army would cross south of Ries, while the U.S. 9th Army would assault between Rheinberg and Wesel. The attack was timed for the night of March 23 to exploit the cover of darkness and the element of surprise. Thousands of artillery pieces were concentrated along the river, creating one of the most intense bombardments of the European campaign. More than 5,500 guns opened fire simultaneously, turning the opposite bank into a wall of fire and smoke. When the barrage lifted, assault boats carrying American and British infantry began their approach, followed by engineers towing pontoon sections behind amphibious tractors. The crossing at Wesel symbolized the unity of Allied effort at the war's end. British, Canadian, and American units worked side by side under one plan, supported by an air armada of more than 3,000 aircraft. Behind the spectacle of fire and steel lay a deeply logistical achievement, the culmination of lessons learned from years of amphibious and river operations from Normandy to the Ruhr. The Rhine, once envisioned by Hitler as Germany's unbreakable frontier, was about to become the passageway through which the Allies would end his empire. Operation Plunder was not just another offensive, it was the final demonstration of Allied coordination, engineering mastery, and strategic patience. Every ton of material, every plank of bridge, and every gallon of fuel had been positioned with mathematical precision. When the first pontoon touched the Rhine that night, it was the result of months of planning and years of experience distilled into one decisive moment. The crossing at Wesel would mark the turning point when the war in the West ceased to be a campaign of advance and became a race to the finish line of victory. When the artillery preparation finally ceased in the early hours of March 24, 1945, The night sky over the Rhine was no longer dark but glowing red from the fires that had consumed the eastern bank. The thunder of more than 5,000 Allied guns faded into an uneasy silence broken only by the hiss of the river and the occasional crack of German counterfire. That moment of transition, from bombardment to movement, marked the beginning of the most dangerous phase of Operation Plunder. For the men of the U.S. Ninth Army, and especially for the engineers of the 17th Armored Engineer Battalion, it was the signal to begin. Their assigned sector lay just south of Wesel, one of the most heavily defended points on the lower Rhine. The Germans had fortified the opposite bank with trenches, machine gun nests, and artillery positions hidden among the ruins of factories and warehouses. Despite weeks of bombing, observers remained active in the church towers and along the dikes, ready to direct fire the moment the smoke lifted. Every meter of shoreline was within range of enemy guns. Yet it was here, under these conditions, that the Americans would attempt to assemble a floating bridge capable of carrying tanks and trucks across the river. The engineers moved in as soon as the last shells fell. The artillery barrage had softened the defenses but not eliminated them, and the Germans were quick to respond. Sporadic shelling began almost immediately, forcing the engineers to work in bursts, ducking for cover between tasks. They wore steel helmets and heavy rubber waders, carrying their tools, ropes, and anchors across the muddy ground that had been turned into a swamp by the shelling. Every step was uncertain, every noise seemed amplified by the fog and smoke that still hung over the river. To conceal their activity, smoke generators lined the western shore, spewing thick white clouds that drifted low over the water. The artificial fog, combined with the night's humidity, made visibility almost zero. It was both a shield and a curse. Under its protection, the engineers could move relatively unseen, but they could barely see one another. Communication depended on shouted instructions, hand signals, and the dim light of lanterns reflected on wet metal. Many of the men worked half-blind, guided only by touch and muscle memory. By midnight, the first sections of pontoon equipment reached the riverbank. Trucks from the 1308th Engineer General Service Regiment unloaded inflatable rubber pontoons and aluminum frames. Each pontoon weighed close to 1,000 pounds and required a team of men to maneuver it down the steep embankment. The current of the Rhine was strong enough to tear the boats away if they were not immediately anchored. Ropes snapped taut as teams fought the pull of the water, hammering stakes into the mud and tying lines to anything that would hold. The first pontoon hit the water around 1 a.m. The sound of its splash was drowned by the low hum of engines and the distant rattle of machine guns. Working by the dim light of hooded lamps and, at times, by the glow of burning oil on the far shore, the engineers inflated, aligned, and secured each pontoon in a precise sequence. One group handled the anchors, another adjusted the spacing, while a third prepared the treadway sections, the steel panels that would form the bridge's surface. Each section was nearly 10 feet long and had to be bolted in place while floating on the moving river. German artillery fire intensified as the night went on. Shells whistled overhead and exploded along the bank, showering the engineers with mud and water. Several pontoons were punctured and had to be replaced immediately. Yet the men continued, driven by training and the knowledge that the entire Ninth Army's advance depended on their success. Behind them, waiting in the dark, were hundreds of vehicles, tanks, supply trucks, ambulances, all halted until the bridge existed. By dawn, the first third of the bridge was already in place. The engineers, drenched and shivering from the cold water, worked with mechanical precision, bolting and aligning each new segment as if on a factory line. The light of morning revealed the extent of their effort, rows of pontoons stretching out from the riverbank, smoke curling over the surface, and the silhouettes of men moving like shadows across the floating structure. The current tugged constantly at their work, but the bridge held. What began as a plan on a map had become a living structure of steel, rope, and human endurance. Each pontoon set afloat brought the Allied armies one step closer to the other side of the Rhine. The catalyst for the crossing had been unleashed, not a sudden burst of heroism, but the relentless, methodical labor of engineers who built a road across water while shells fell around them. By sunrise on March 24th, the bridge was no longer an idea. It was a line of survival stretching from the muddy west bank toward the fading smoke of Germany's last defense. The M2 Treadway Bridge was the culmination of years of American engineering refinement, an elegant balance of portability, strength, and speed. It had been designed for exactly this kind of situation, a major river crossing under fire, where no permanent infrastructure remained. Its structure was deceptively simple. Inflatable pontoons, made from reinforced rubberized canvas, provided buoyancy. Over them were placed steel treadway sections, interlocking panels with built-in tracks shaped to fit the width of a tank's treads. When properly assembled, the bridge could bear a load of up to 50 tons, enough to carry a Sherman or even the heavier Pershing tanks. It was a design born not in laboratories but in the mud of previous campaigns, from Sicily to the Seine, and now it was being tested on Europe's most formidable river. The assembly followed a methodical rhythm learned through months of training and experience. The engineers of the 17th Armored Engineer Battalion worked in rotating teams, each responsible for a specific task. The first teams prepared the riverbed and shoreline, anchoring guide cables that stretched across the Rhine. These cables were critical. They served as the spine of the entire bridge, preventing the current from twisting it out of alignment. Using amphibious tractors and boats, other teams ferried pontoons into place one by one. Each pontoon was inflated on shore, then pushed into the water with manpower and ropes, guided into its assigned position along the tensioned cables. Once 2 pontoons were anchored side by side, the next phase began, installing the treadway sections. Each steel panel weighed several hundred kilograms, requiring 4 to 6 men to maneuver it into place. The panels were lowered onto the pontoons using cranes when possible, or by brute force when the cranes could not approach the unstable banks. Bolts and steel pins secured the sections, forming a continuous, floating road that flexed with the river's motion. The engineers worked with astonishing precision, aligning each connection so the tanks could later roll smoothly across without losing traction. Every 20 feet, they stopped to test the stability, tightening bolts and adjusting the anchor lines to compensate for the current. The anchoring system itself was a feat of calculation. From the western shore, long steel cables extended diagonally downstream, fixed to large winches and buried anchors. These held the bridge against the flow, allowing it to flex but not drift. Smaller side anchors were driven into the riverbed using pneumatic hammers, each line adjusted with careful measurements to maintain equal tension. The engineers constantly monitored the pull of the river. Even a few inches of movement could warp the structure. They had learned from earlier crossings that an unbalanced anchor could snap and send entire sections adrift, so they triple-checked every knot and clamped despite the deafening noise around them. Illumination was limited to hooded lamps, and the red glow of flares reflecting through the smoke. The men's hands worked by touch as much as by sight. They used wrenches, crowbars, and mallets slick with water and mud, their gloves soaked through. When a shell landed nearby, they froze instinctively, then resumed their rhythm as soon as the echoes faded. Each explosion sent waves crashing against the pontoons, forcing constant adjustments to keep them level. Several times, completed sections had to be detached and realigned when the river shifted or a pontoon began to deflate under strain. Replacement pontoons were dragged into place, inflated by foot pumps and compressors running from truck-mounted generators. The process repeated endlessly, pontoon, panel, bolts, anchors, each motion a small victory over the river. By dawn, the engineers had advanced far into the current, their bridge stretching outward like a metallic spine over the water. The steady clank of metal on metal became its own kind of heartbeat. Trucks lined the western bank, their headlights dimmed under tarps, waiting for the signal to move. Officers paced the shoreline, checking progress against their stopwatches. 6 hours after the first pontoon entered the water, the bridge spanned nearly 1,150 feet, roughly 350 meters, across the Rhine. When the final treadway section was locked into place, the structure groaned but held firm. The river's current pushed hard against it, but the anchors bit deep, and the pontoons rose and fell rhythmically with the flow. The engineers tested it first with jeeps and then with half-tracks, confirming that the flex of the steel sections remained within tolerance. The M2 bridge swayed, creaked, and shifted, but it did not yield. It was not a monument of beauty, but one of necessity, assembled in darkness, baptized by fire, and made strong by the will of the men who built it. In less than a single night, they had turned a river once called uncrossable into a road wide enough for an army. When the last bolts were tightened and the bridge stretched unbroken from bank to bank, dawn was already painting the Rhine in dull gray light. The engineers stepped back for the first time in hours, their faces streaked with soot and mud. They had no time for rest. The bridge now had to prove itself under real weight, under the pressure for which it had been designed. It was one thing to float a structure across the river. It was another to make it carry an army. The first test began with the smallest vehicles, jeeps and reconnaissance trucks carrying communication equipment. Their drivers advanced cautiously, guided by engineers waving flags along the sides of the treadway. The pontoons dipped slightly under the tires, the steel plates flexing but holding firm. The rhythmic slapping of water against the inflated pontoons echoed across the mist. The bridge shifted and swayed with each vehicle, but the motion remained within the expected tolerances. As soon as the first jeep reached the opposite shore, a cheer went up from the men watching. The crossing was functional. Next came the heavier supply trucks loaded with ammunition, rations, and medical supplies. Each vehicle was spaced carefully, moving at a crawl to maintain even weight distribution. The engineers monitored the deflection of the treadway sections using measuring rods placed at intervals along the bridge. Under load, the pontoons sank deeper by only a few inches, well within design limits. When one truck struck a loose connection and the steel rattled like thunder, several engineers rushed to tighten the bolts and reinforce the anchor cables. They worked quickly, aware that the slightest failure could block the crossing and jeopardize the entire offensive. Once the supplied vehicles cleared, the real test approached. A column of M4 Sherman tanks from the 30th Infantry Division waited at the water's edge, engines idling, exhaust drifting into the morning haze. The first tank commander received the order to advance. The tank rolled forward, its tracks clanking against the steel plates, leaving a trail of vibration that rippled through the bridge. The pontoons dipped sharply under the 40-ton weight, the steel treadways groaning as they adjusted to the strain. Halfway across, the tank paused for a brief moment, the crew scanning for any sign of failure. The bridge held steady. With a roar, the tank continued, its tracks leaving wet impressions of mud and oil on the glistening metal. When it reached the far bank, the engineers exhaled collectively. The following tanks advanced in steady rhythm, one after another, maintaining intervals to reduce stress on the structure. The bridge swayed slightly with each passing vehicle, but its balance remained true. Observers on both banks recorded the test results with stopwatches and notebooks. Each vehicle's speed, load, and position were logged for later analysis, a practice refined through years of combat engineering experience. Behind the Shermans came armored recovery vehicles, half-tracks, and self-propelled guns, their combined weight pressing the limits of the design. The M2 Treadway's modular system flexed but did not fail. By mid-morning, the traffic had become continuous. Convoys stretched for miles, winding down the muddy approach roads toward the river. Military police directed the flow, ensuring that one-way movement was maintained and no vehicle lingered longer than necessary. The surface of the bridge was slick from condensation and spray, forcing drivers to keep a steady pace. Occasionally, artillery shells landed nearby, sending up columns of water, but the men ignored them. Their focus was on the rhythmic advance of machines across the river, a mechanical heartbeat marking the pulse of the entire operation. As the sun climbed higher, the bridge took on the weight of an entire army. More than 1,000 vehicles crossed that day, trucks, jeeps, tanks, ambulances, and artillery pieces. Engineers remained on constant duty, tightening bolts, pumping air into pontoons, and realigning cables as the current shifted. Each adjustment was small but essential. By afternoon, the eastern shore was alive with movement, tanks forming up for the next advance, infantry unloading supplies, and medics setting up aid stations. The once quiet farmland beyond Wesel had become a logistical artery. By evening, the crossing was declared a full operational success. The 17th Armored Engineer Battalion had completed and proven the bridge within 12 hours of starting construction. The Rhine, long considered an unbreachable barrier, now carried the unbroken flow of American armor. The engineers, exhausted but triumphant, watched as the last rays of sunlight glinted off the wet steel panels, each one scarred by tools, mud, and the weight of victory. The M2 Treadway bridge had endured its trial by fire and water, and with it, the path to Germany's heart was finally open. The speed and precision of the Wesel bridge construction astonished even the Allied command. In less than 15 hours from the first pontoon touching the water, a fully functional, tank-capable crossing spanned the Rhine, an engineering feat that exceeded all expectations. The bridge built by the 17th Armored Engineer Battalion became operational faster than any comparable structure in that phase of the war. Its completion meant that by the morning of March 24, 1945, the U.S. Ninth Army could begin moving its armored divisions across the river without pause. The bridge turned what had once been Germany's proudest natural defense line into a logistical highway. The rapid establishment of the crossing had immediate tactical consequences. Within hours, entire regiments of the 30th Infantry Division and supporting armored units began to pour across the river, reinforcing the British and Canadian forces advancing north of Wesel. What had begun as a narrow bridgehead on the eastern shore expanded rapidly into a broad front stretching several kilometers. The coordination between infantry, armor, and engineers achieved a level of efficiency that the Wehrmacht could no longer counter. German resistance, fragmented and undersupplied, crumbled under the pressure of relentless Allied mobility. The bridge was not just a structure, it was the physical manifestation of Allied momentum. By March 25, hundreds of vehicles an hour were crossing. Ammunition trucks, ambulances, and fuel convoys streamed eastward while returning lanes carried prisoners, wounded soldiers, and repair crews. The Rhine crossing at Wesel became the main artery of the Ninth Army's advance toward the Ruhr. Commanders credited the engineers' speed and precision with preventing the Germans from re-establishing a defensive line. Without that immediate bridge, the attack could have stalled on the western bank for days, giving the enemy precious time to regroup. Instead, the Allied forces pressed forward continuously, maintaining the tempo that defined the closing weeks of the war. The effect rippled far beyond the battlefield. The success at Wesel proved conclusively that large-scale river crossings under combat conditions were not only possible but could be executed with speed, coordination, and minimal losses. It was the culmination of years of innovation in portable bridging systems, the refinement of the M2 Treadway design, and the disciplined training of engineer battalions who had practiced such maneuvers in every theater from North Africa to the Ardennes. Military observers from multiple Allied nations documented the operation in detail, recognizing it as a model for modern combat engineering. For the Corps of Engineers, Wesel became a case study in efficiency and adaptability. Reports following Operation Plunder emphasized not only the technical success of the bridge but also the organizational precision behind it, logistics, timing, and communication under fire. In post-war analyses, American military academies highlighted the operation as a demonstration of how engineering could shape strategic outcomes. The bridge's completion within 15 hours was entered into official records as one of the fastest heavy-class river crossings of the entire European campaign. The psychological impact was equally profound. For years, German propaganda had proclaimed the Rhine as an impregnable barrier, the final shield of the Reich. The sight of Allied tanks rolling across a floating bridge near Wesel shattered that illusion completely. Civilians and soldiers alike saw photographs of American armor crossing the river where the Third Reich had once sworn no enemy would ever tread. The myth of the Rhine collapsed overnight, replaced by the reality of Allied superiority in planning, logistics, and engineering. The experience of Wesel transformed post-war military doctrine. The M2 Treadway system, refined through the lessons of the Rhine, became the standard bridging equipment for American forces for nearly 2 decades. Its principles influenced later modular bridge systems like the M4 and the improved MGB, medium girder bridge. Manuals written after the war used the Rhine crossings as textbook examples of combat engineering, citing the 17th Armored Engineers and their counterparts as models of discipline under fire. In the years that followed, the crossing at Wesel entered the collective memory of the U.S. Army engineers as proof that technical skill and courage could overcome even the most entrenched natural obstacle. The operation bridged more than a river. It bridged the gap between warfare driven by brute force and warfare driven by precision and planning. The men who built that bridge did more than connect two banks of a river. They connected the momentum of the past to the victory of the future. The Rhine, once the wall of the Reich, became the road to its end. The pontoon bridges at Wesel stood as the final great engineering triumphs of the European war. They were not only structures of steel and rubber but symbols of how far military engineering had evolved by 1945. When the U.S. Ninth Army completed its crossings of the Rhine, the war in Europe entered its final stage. Within 6 weeks, Germany surrendered, and the rivers that had once defined its defenses became highways of occupation and reconstruction. The bridges built across the Rhine, temporary, improvised, yet monumental, became some of the last great acts of creation before peace returned to the continent. In the months that followed, engineers dismantled most of the pontoon structures as quickly as they had built them. The Rhine's current reclaimed its banks, and the scars of war slowly began to fade. Yet the legacy of those bridges endured. Their design and execution became a foundation for post-war military doctrine, influencing the next generation of portable bridging systems. The success of the M2 Treadway under combat conditions validated the modular approach: small, transportable sections assembled rapidly into a structure strong enough for heavy armor. These lessons were directly applied in the development of the improved M4 floating bridge and later in the British-American medium girder bridge system, both of which carried the DNA of the Rhine crossings. In the years after World War II, the U.S. Army Corps of Engineers incorporated the Rhine experience into its training programs. Manuals and engineering textbooks used Operation Plunder as a case study in coordination, logistics, and adaptability. The Wesel Bridge was cited not simply for its technical execution but for the way it demonstrated the synchronization of engineering, firepower, and command under the pressures of real combat. At West Point and in engineer schools across the United States, cadets studied diagrams of the bridge, learning how planning and discipline could turn a river once thought impassable into a navigable road. The influence of the Rhine crossings extended far beyond Europe. During the Korean War, American and United Nations engineers built temporary bridges across the Rhine River using methods derived directly from the M2 Treadway design. In Vietnam, modular pontoon bridges and ferries allowed convoys to cross jungle rivers under fire, echoing the work done 3 decades earlier at Wesel. Even in peacetime operations, disaster relief, flood response, and infrastructure repair, the principles of rapid modular bridging continued to guide the Corps of Engineers. The philosophy born on the Rhine had outlasted the war itself. In archives and museums, the memory of those bridges survives in black and white photographs and reports. The U.S. Army Engineer Research and Development Center preserves collections showing soldiers waist-deep in cold water, hauling steel panels into place while smoke drifts over the river. Some photographs capture the eerie beauty of the operation: the soft glow of lamps through fog, the outline of a pontoon against the dawn, the faint silhouettes of tanks crossing a floating road toward the heart of Germany. These images remind future generations that victory in modern war was not achieved by destruction alone, but by the capacity to build under fire. Among veterans, the Rhine crossings became a story of pride, a demonstration that engineering was not merely a supporting branch, but a decisive arm of combat. The men of the 17th Armored Engineer Battalion and other units who built those bridges were later recognized for their exceptional performance, receiving unit commendations from the U.S. Army. Yet few of them saw themselves as heroes. They viewed their work as part of a larger purpose: to restore movement where destruction had halted it, to connect instead of divide. Decades later, historians and engineers alike continued to study the operation as the perfect fusion of human endurance and mechanical ingenuity. In the grand narrative of World War II, the pontoon bridges of Wesel represented a quiet victory, a moment when creation triumphed over chaos. The river that once separated nations had been crossed, not by sheer force, but by structure, calculation, and resolve. Long after the smoke cleared and the bridges were gone, the spirit that built them remained, shaping the very idea of what engineering could achieve in the service of humanity. The story of the Rhine pontoon bridges was ultimately the story of how human intellect and determination overcame the most destructive forces of war. In an age defined by mechanized violence and industrial ruin, those bridges stood as rare monuments to creation amid devastation. Where concrete spans had been shattered and cities reduced to ashes, men returned with ropes, bolts, and courage to build again. Each pontoon that floated upon the dark waters of the Rhine represented not only a technical achievement, but an act of defiance against the logic of destruction that had consumed Europe for 6 years. The bridge was not only a means of crossing, it was proof that humanity still possessed the will to connect what war had divided. For the soldiers who built it, the bridge was more than a structure. It was a statement of purpose. They had spent years moving through a continent of wreckage, watching roads vanish under bomb craters and towns disappear under artillery fire. Every battle had been a process of tearing down. At Wesel, for once, they built something new. The river that had symbolized the last boundary of the Reich became a line of renewal. The men worked without slogans or ceremony, unaware that they were participating in an act that would outlive them. Yet their labor carried a quiet symbolism, the transformation of the tools of war into instruments of progress. Steel once used to destroy cities was now used to link them. In that moment, engineering became a form of redemption. The same discipline that had designed tanks and bombs now proved capable of restoring movement and purpose. It showed that knowledge, even knowledge born from war, could serve life rather than death. The bridge across the Rhine was not a monument in the traditional sense. It would not stand for generations, nor be carved in stone. Within weeks it would be dismantled, its sections reused or stored, its surface once again claimed by the river. But its true permanence lay in the idea it embodied, that order could be wrested from chaos, that men could still build under fire and find meaning in their craft even when surrounded by ruin. The Rhine crossings also reflected something larger about the 20th century. They symbolized a world learning, painfully, that victory was no longer measured solely by conquest but by reconstruction. The war had been fought with machines, but it was ended by builders. When Allied tanks rolled over the Treadway Bridge at Wesel, they carried not just weapons but the weight of civilization's return to reason. Each bolt tightened by an engineer, each pontoon anchored against the current, was a gesture toward a future where knowledge would heal rather than harm. For the men who looked back on that river years later, the sound of clanking metal and rushing water often replaced the noise of battle in their memories. They remembered the teamwork, the precision, the shared exhaustion, and the strange calm that came from creating rather than destroying. Some would go on to become civil engineers, architects, and teachers, carrying forward the lessons learned under the smoke of Wesel. They had discovered that even in the darkest hour of humanity, the capacity to build, to restore function, to reconnect, remained the most enduring expression of strength. The Rhine Bridge was temporary, but its message was not. It spoke of a world where knowledge triumphed over chaos, where cooperation defeated isolation, and where the act of construction itself became a moral victory. The soldiers who built it left behind no statue or marble inscription. Instead, they left an example of discipline and ingenuity that still resonates in the quiet halls of engineering schools and military academies. They had shown that progress is not born in peace but proven in adversity, when creation is the rarest and most courageous choice a person can make. When the bridge finally came down and the river flowed freely once more, it carried with it fragments of that night, bits of steel, traces of oil, and the memory of men who, for a few brief hours, turned war's machinery into a pathway toward peace. In the stillness that followed, the Rhine no longer divided nations. It reflected the enduring image of human resilience. It was there, on that floating road of steel and willpower, that the engineers of the Rhine proved that even in the heart of destruction, mankind remained capable of building the way forward.